Question 1a is a backwards expansion question. You have to make up an expansion question which would produce this when you multiply it out. This sort of thing. That's what you get when you multiply it out. You just look for what you can see twice. That's a 3. Physically see it there. It's hidden in there. And you just muck around until you get something that produces this when you multiply out the brackets. So once you've written your answer for this, so once you've filled that space, and that space, multiply out the brackets and make sure you get what you started with. Now for this one, multiple choice out of 4, either multiply those powers, add those powers, subtract those powers, or divide those powers. Maybe if you want to check which one to do a simple example to work out what that is and see whether it matches timesing, adding, subtracting, or dividing the powers. Same again for this one. Just treat it as multiple choice out of those 4. Okay, question number 2 is a classic Dear Mr. Examiner question, and it's also a question where you have to read carefully through it and make sure you've used all the information.
Okay, so give them an actual...
So if it's a square and its perimeter is 16, then you can work out what these side lengths are. And once you've worked out what those side lengths are, you can work out what this side length is and this side length. And then you'll have everything you need to work out the area of this triangle, the area of this triangle, and when you've got the area of those two triangles, then subtract it from the area of the square, which is just that times that. Don't forget to make sure that you've worked out the answer to what they actually want. They want the proportion of the area that's shaded. So they don't actually want the shaded area, they want the proportion of the total that shaded area is. So if the total area is 20 and the shaded area is 13, they want a fraction. Now question number 3 looks like it might be a tree diagram because it involves 2 things happening, the dice and then the spinner. So you might want to do a massive great big tree like this. So 6 forkings there for the dice and 5 forkings there for the spinner. And you work out the summary, so getting 1 on the dice and 1 on the spinner would lead to 1, 1. And then when you work out the expected profit, you use the idea that you can work out expected money by looking at your options. So if there's a 60% chance of £5 and a 40% chance of £10, then the expected money to be made is that times that, which I think is £3, that times that, which I think is £4, and then you add up those 2 results. So if you have a 60% chance of getting 5 and a 40% chance of getting 10, on average you'll get 7. And I think that's the principle that you're going to use in question 3. Okay, definitely draw a diagram for this. And once you've got the A, B and the C on it, once you've decided where the A, the B and the C go, I copy out the triangle without the A, the B and the C on it. The reason for that is that these are the official labellings for the sine rule, cosine rule business. So I tend to avoid putting them on a diagram because they'll mess up the diagram when I try to put these on as well. I won't know what's the difference between an angle, capital A, and a point to capital A, for example. But anyway, so you put on your 7, you put on your 4, and do a bit of Dear Mr. Examiner to find out what the other side must be. and then see whether it fits Pythagoras. So right angle triangles really have to fit Pythagoras. So 6, 8, 10, that squared plus that squared equals that squared. Is that true? If the answer is yes, then it's a right angle triangle. So that's what you do for this one. You're definitely going to want to label all your working for this nicely. I think you do. I think this is a topic where if you double one thing, you double the other. So if you double the area of your card, you're going to double its mass. I would write down a sentence like one sheet, so sheets of 1 would have area 1/8, and it would have mass . So it looks to me like a triple ratio, where you've got 3 things that are being talked about. So I would muck around until you've got the number 25 for sheets, and if you do red dudes until these match, then the mass will be whatever's here. Six A, fractions wrap doesn't work on mixed fractions, so I convert them into improper fractions. Remember, the way to convert from mixed to improper is to go this times this and then add this. So 10 times 5 is 50, plus 3 is 53, and then transfer that original denominator over, and then just use the fractions wrap, so top times top, bottom times bottom. Just do part B with experimentation. There's only so many ways in which you can put 3s, 4, 5 and 6s in here. It might help you to save some time if you remember that the bigger a number that goes in the bottom of a fraction, the lower the value of the fraction is. That might just help you save some time in getting this total to be as big as possible. But you will need to muck around for this in order to get your answer. One of these is a backwards percentage question. So remember, you use this little technique. So if something was reduced by 10%, you'd say 90% is whatever it is. Let's say it's 180. So the reason why I've said 90% is because it's 10% reduction. So you go 90% is 180, 10% is 20, 100% is 200. And that's the original. And you can apply that same logic just with fractions instead of percentages. And don't forget your subtraction here. The reason why I got 90 was because it was 10% off. So if it's 1/3 off, just like I subtracted 10% from 100%, you want to subtract 1/3 from 1. And now, remember, this is a non-calculator paper, so you can't just bump this in. The final thing you're going to be doing is square rooting. So your goal is to try and get this to a square number without making too many changes. See if you can get it to close to root 25 or root 16. Not just whole numbers that work. So for example, root 36 over root 25 is 6 over 5. Just square it at the top, square it at the bottom. And so what I'm saying is hopefully you can get to that, or something like this by just some fairly minor changes. So you might want to change that to you might want to change 4.98 to 5, etc, etc. For number 9, I'd use the smaller and simpler strategy. Like, what do you normally do with the volume on one of these? If it was 3, 5 and 7, I do the area of the front times how far it goes back. So whatever you do for those, if it's that times that gets you the area of the front, it'll be that times that gets you the area of the front for this. Whatever works on the smaller problem, the smaller, simpler problem, will also work on the harder, more complicated problem. Now I normally tell you that the word is becomes equals, is less than becomes that. So instead of is less than 900 will become this. And you just have to work out what it is that's less than 900, it's the volume, and that's why I was talking about these. That method here is how you come up with an expression for the volume of that cuboid, and then you do red dots after that. This is a highly specific method, if it was 0.245, you go x equals 0.2454545. And then 10x equals 2.4545, etc, etc. Now, question number 11. It's an example of how you have to be willing to substitute into formulas even though what you're substituting in is algebra. All the formulas you need for this are here, and the formula you need for this is not so much a formula but just the principle that the volume of a cylinder is the area of the top times how far it goes down. So what would that normally be? If that was a 10 and that was a 4, it would be pi 10 squared times 4, so the area of the top times how far it goes down. If the volume is that for this, then just apply the same principle for that. Area of the top times how far it goes down. Now, remember, in order to work out the height of this cone, one of the things about a circle or a cylinder, a circle or a sphere, is that it doesn't matter which direction you go to get to the edge, it'll always be the same distance. Therefore, if you go straight to the top, that'll be an x, which means you can work out what the height of this fellow must be. If that's x and that's 5x, you can work out what this guy must be. Now, you're told that the volumes of this and this are the same, so when you've got your two expressions for this and this, just stick them on either side of an equal sign and then do red dots. Now, question 12 you'll be in a tight spot for, unless you can remember some properties of a parallelogram. Two of the properties are pretty straightforward just from the name. That's parallel to that, and that's parallel to that. The angles in opposite corners are equal, so that's equal to that, and that's equal to that. And a famous property of a parallelogram that you're going to eventually need to know off by heart is that the diagonals bisect each other. So when that comes along and cuts AC, that's equal to that. And when this comes along and cuts BD, that's equal to that. And so now you should be sorted to prove that they're congruent. And two of your reasons are going to be probably property of parallelogram. Maybe you need to say three things are equal, and then your final conclusion will be either AAS or SSS or one of those four possibilities. Question 13 is naming, stating and equating. And in order to prove that he's wrong, I would just work out the mean mark for the whole test myself and just show that it's not 75%. Probably the simplest way rather than trying to do a fancy explanation. So how do you work out a mean? You work out a total. So let the total for boys be X. Let the total for girls be Y. And now just form an equation. You've done means for years. It's the total divided by how many there are equals the answer. So I'll do the girls one for you. Y over 10 equals 70. So do that for the boys. So something divided by something equals something. And then do red dudes and work out what the mean for the whole group will be. Just to check you're understanding me, when you work out the mean for the whole group, you're going to be dividing by 25 because that's how many people there are in the class. Now, even if you haven't done this business to do with square root symbols yet, you can definitely just expand the bracket that's fitted to Mr. Examiner to get 1 mark out of 2. So you know, just do the smiley face. And then hopefully the mark scheme will give you 1 mark just for doing that. Okay, question 15. I remember that means cube root, so you have to think of a number which, when you times it by itself in a repetition of 3, gives you that. And so I just do that by trial and error. You need to get the 8, and you also need to get to the 10 to the power of 6. So you're probably actually going to end up having 6 things. So you need to write the same thing all 3 times here. And these bits are going to have to give 8, and these bits are going to have to give 10 to the power of 6. Now remember, a fraction power just means a rooting. 144 to the power of a half means that you have to think of a number which gives you 144 when you times it by itself. And remember, negative powers should temporarily be ignored. You then do your thing, and then write the answer under a fraction. So for example, 2 to the power of -3 is 1 over 8. And so you got your answer for that, and you got your answer for that, just multiply them together. Now this can be done with a strategy that we haven't done yet, but you can also just muck around. So if you had the number 3 and you're planning to get to 81, what power could you use? Well, there's a clue up here. Fractions come out of a negative power process, and somehow you've got to turn a 3 into an 81. So just muck around with different possibilities for what 2x might be, and then once you work that out, you can find out what x is. Now question 16 is a technical term that we haven't done yet. Now question 17 quite a tricky question. So Liam, Sarah and Emily shared some money in the ratio 2:3:7. If I was told that the total was 80, I would say 2 parts to 3 parts to 7 parts is 12 parts. So I would go 12 parts is 80, therefore 1 part is 80 over 12, and then I'd be away. However, 80 is not the total, it's something else. So if you think carefully, you'll still be able to write that something is 80, and it will still be a certain number of parts, but it's not 12 parts because that's not the total. It's the difference between Emily and Liam. So you basically need to fill that gap and then you're away. Now, this is an example of nested similar triangles. The reason why I know they're similar is because that PQ is parallel to LM, so that's equal to that by corresponding angles from year 7. So we want P and Q and LPQ. So in fact these aren't nested similar triangles at all. In fact they're not nested triangles. I was thinking that that would be one triangle and that would be the other. They want the area of this guy. Well, for this question I'd probably maybe use naming, stating and equating. But I'm not sure. Maybe I think what's special about the numbers. So if that's 8 and that's 16, that looks like doubling to me. Anyway, I'm not sure. For question 19, I would just do a bit of mucking around. So for pattern 1, you could count the white, count the grey. And I would treat these like an ordinary linear sequence, maybe come up with a rule for them. I'm just using that same method you often see with 1, 4, 7, 10, you know, when you write down a guess and then you fix up your guess. So I do that for those two. Now, this one's really straightforward, an illustration of how there can be easy questions towards the end of a paper. Don't try and do anything with the whole shape, instead just work on the key points. Remember, that's a left versus right instruction, that's a top versus bottom instruction, and you're away. And for this one, definitely use tracing paper. This is classic Dear Mr. Examiner. Or it might be naming, stating and equating. You're told that they're identical, so let's call that X and that Y. So that'll be X, that'll be Y, that'll be X, that'll be Y. So that'll be Y minus X. And maybe state some equations. So if that's Y, and putting in an extra x shifts that down, and x plus y has to be 7. So you might get simultaneous equations out of this, I'm not sure. And you'll definitely get simultaneous equations out of question 22, because you say let x be the number of adult tickets, y be the number of child tickets. If you're not sure how to write down the algebra, just imagine that this was 10 and this was 20. Wouldn't it be 3 times 10 plus 1 times 20? But instead of 10 and 20, you write the algebra. So 3 times 10 plus 1 times 20. And then you do it again and you get simultaneous equations.